This week we are going to get into some word problems involving arc length, sector area, linear and angular speed. So for today, we have a few problems that involve our arc length. I know that's something that we talked about on Friday, just very briefly, just learning what the formulas are, but today we're going to actually apply those things. So just to recall what arc length is, so our formula for arc length, S is for arc length. And then it's r, the radius, times theta. And remember, theta is in radians. Okay, so if we had a central angle, so that means it's coming off the center of the circle, and this was our theta here, then our arc length would be the arc that's intercepted by that particular angle. So that would be my S. Okay, so here's an example. A circle has a radius of 4 inches. Find the length of the arc intercepted by a central angle of 240 degrees. So just using your formula, S equals R theta. So we have our radius, which is 4 inches. We have our theta, which is 240 degrees. But we have to make sure our theta is in radians. So we need to convert that. You can do this kind of all in one step if you want. We need to multiply by pi over 180. Okay, so when we're doing arc length, we're going to go ahead and just multiply everything out. So if you punch this all in your calculator, then that's going to give us 16.76. If we're rounding to decimal places, that would be inches because our radius was given in inches. Okay, so here's another example, just given a diagram. This one you have to be careful with because they have it marked here that it's 120 degrees. So you have to be careful because the arc that they're looking for is actually this arc right here. So you need to recognize that theta that you're looking for, theta that's intercepting the arc that you're looking for, is actually 240 degrees. So this is actually the same as the first example, but I just wanted to show you, in case they mark one angle, but you're actually looking for the opposite arc. So, and then this would be just the same as number one. Right, and then example 3 here, find the central angle in radians and in degrees that is formed by a radius of 12 feet and an arc length of 31 feet. So this is still our arc length formula. So S equals R theta. They give us the arc length, which is 31. They want us to find the angle. So they give us that the radius is 12 feet. So it's 12 theta. Now they want us to find it in radian and in degree measure. So even though you're not going to see pi in your answer, if you isolate theta here, just by dividing both sides by 12, because the formula has theta in radians, this answer will then be also in radians. So theta is going to be 2.58 radians. There's no way to really extract pi out of that because pi is irrational. So if you divided by 3.14, it really wouldn't be an exact answer. Now that you have that in radian, you want to put that into degree. So all you have to do is take your 2.58, and you're still going to use that same conversion, 2.58 times 180 over pi. And then you just multiply that all out. So that's going to be approximately 147.8 degrees. So there's our degree measure, and here's our radian. So when you start off with the formula, S equals R theta. This theta, the unit on this is radian. So when you have to solve for theta, that is automatically in radian. If they ask for it in degree, then you just want to go ahead and use your conversion, 180 over pi, and then that'll be your degree measure. Okay, so one more example here. So they want us to find the distance between the cities. Assume that the Earth is a sphere with a radius of 3,960 miles, and the cities are on the same longitude. So the same longitude, so it's basically they would be on the arc of the circle. So we just draw a circle here. So if they're on the same longitude, then they're along this arc because this would be the longitude. It's the one that runs from north to south. Okay, so, and then this would be our equator that runs through here. So they say that Johannesburg is 26 degrees south. So that would be 26 degrees in here. And that Jerusalem is 31 degrees north. So that my 31 would be in here. So your theta is actually the sum of those. So there's our theta. And then they've given us R, which is the 3,960 miles. So again, we need to make sure we put this into radian, but you can kind of do that all at once in the formula if you want. So we can do our S equals R theta. So S equals R, which is 3960 times our theta, which is 57 degrees. Putting that in the correct unit, we're going to have to multiply by pi over 180. And then all you got to do is punch that in your calculator, and you get approximately 3,939.56. And then that'll be in miles because the radius was given in miles. Okay, so we're just going to deal with the problems with arc length today, and then tomorrow we'll get into linear and angular speed. So if you guys go to page 3 of this document, I'm going to have you do numbers 1 through 7, because then when you get to number 8, then this starts into your linear and angular speed. So numbers 1 through 7, and then I'll post the answers later this afternoon. Let me know if you have questions. Have a great day.